So continuation video of direct method. So we have to calculate the arithmetic mean for this given data, the marks of a student that is obtained in the economics class test. So we have to calculate this arithmetic mean. So according to this direct method, we have what it said is that the number of observations, sum of all the number of observations in a series divided by the number of observations. So how much is the number of observations? 1, 2, 3, 4, 5. So divided by n. And what we will get is 56.2. So that is how we calculate the direct method under ungrouped data for arithmetic mean. Sum of all the number of observations divided by the number of observations. We can conclude that the average mark of students in the economics test is 56.2. So next up, under ungrouped data, we have assumed mean method. So we have discussed the direct method. So there are certain cases where we are not able to apply the direct method. Suppose if the number of observations in the data is more, or the figures are very large, so it is difficult to compute arithmetic mean by direct method. So the computation can be made easier by using this assume mean method. So in order to save time, in calculating mean when the data is very large, from the data set, you can use assume mean method. So under this assume mean method, you assume a particular figure in the data as the arithmetic mean. So you are not going to find out the arithmetic mean through the formula, but you have to assume one particular figure value that will represent as the arithmetic mean. But by assuming, you are not going to assume simply. You have to assume on the basis of logic or with experience. Then after that, you may take deviations of the set assume mean from each of the observations. And after that, you can take the summation of these deviations and then divide it by the number of observations in the data. So the actual arithmetic mean is estimated by taking the sum of the assumed mean and the ratio of the sum of deviations to number of observations. So symbolically, for assume mean method, we can write like this. So let A be the assumed mean and X be the individual observations and N is the total number of observations, and then D is the deviation of assumed mean. Assume mean from the individual observations, the deviation. So that is D is X minus A. Then you sum up all the deviations as summation D equals summation X minus A, since D is X minus A. And then after that, you find out summation D divided by the number of observations. So this is similar with the direct method again. Now after assuming arithmetic mean, you find out the deviation and then get the summation of the deviation and then divided by the number of observations. Then after this you add A to get the summation X. After this, then add this assume mean and summation d n to get what is called the arithmetic mean. So therefore arithmetic mean is given by n. So that is how we compute the assume mean method under ungrouped data. We are not actually finding the arithmetic mean because the data is too large. So we assumed a particular value, and after assuming that, you find out the deviation of that assume mean method from the individual observations. After that, you find the summation of that deviation and then divided by the number of observations, and then you just add the assume mean a to the summation of d divided by n to get this value, and the formula we derive is this. So a plus summation d divided by n, that is the formula for assume mean method.